I think it might be strange to listen to the fact that the European Commission is investing in space. So there are many other policies that might deserve more attention. But what is very important, and what we tried to explain to policymakers, is that we are doing space for the Earth. So everything that we are doing by launching satellite and observing our planet is really in support of many policies. Today we are mostly speaking about marine area, but it's true that all the other services look in the land management, in the emergency situation in support of civil protection. Another point that is quite important is the border surveillance. We are looking also into aspects of climate change. So really a lot of policies that are very important. With these elements, we had the support of many partners, I have to say. It's true, it's very easy to convince space agencies, but in the end, the main support and the big result is that we had the support of the European Parliament. We had the support of the Council, meaning the member states. And this is very important because when the regulation on Copernicus was adopted, we were in a situation where the budget, there were constraints in the budget, but European Parliament and the Council pushed, they won it. And this is the reason why today we have the budget to run it until 2020, and we cross fingers and we hope to raise it even for the continuation and sustainability in the long term.
Things like the Copernicus system are bringing so many people together. There are government organisations, there are private companies, there are individual scientists working on projects, there are the end users. It's so collaborative, isn't it? All these different people are involved.
Yes, this is true, and what we did with this Copernicus Marine Service is that we defined this marine service as what we call it a core service. This is the common information all these people are looking for. I mean, a policymaker and someone going at sea, they are looking for the state of the ocean. They want to understand the ocean. And so we have these people when we organize a user workshop. We have someone for a governmental policy bureau sitting close to someone in a private company working for the offshore things, or someone for the research. And they are talking about what? About the ocean. What do you think about the temperature? Do you need more accuracy, or what about the resolution? Do you think that we should increase the forecast from 1 week to 2 weeks, or the priority for you is to have the last 2 decades because you, etc., etc. But this is very true. Operational oceanography today is engineers, plus research, plus IT managers, plus marketing people, plus communication, plus the people that are able to translate this into a discussion with the policy makers, etc. It's very, very rich and very dynamic. Well, I like it.
Well, at the moment in the UK, the way we monitor the marine environment is very heavily based on in situ monitoring. So all of the waters around the UK that we are responsible for, we monitor with ships. CFAS is a ship called the Endeavour, and it goes out very routinely to do a lot of the marine monitoring. And we have people to do the marine monitoring. We have smart buoys and a whole complement of really cool gizmos, including gliders, which are great, and they're collecting a lot of data. The thing is, as I said about the southern elephant seals, it doesn't matter how much data you have, you are still collecting point measurements in space and time. So it gets you very, very accurate data at that point. But what about the synoptic overview of what's going on?
So when we say synoptic, we mean a bigger view, that sort of zooming out and
Exactly.
having a bigger look over the oceans. And
Absolutely.
of course, because the oceans are connected, you can't just do something here
Yeah.
and ignore what's happening over
Yeah.
here. So this is the benefit that satellite data has for policymakers, is that it gives you more of the whole picture, not just one point.
Absolutely. And again, any point measurement is absolutely accurate and it's brilliant. But the other thing is you've got that human error that you might introduce. So the way one lab does something might be completely different to the way another lab does something. But with satellites, you have year after year, you have very repeatable data. So you can have a time series that's very stable from year to year. And you can be quite sure that what you're seeing in time and space, again, on that sort of step out, zoom out view, is quite realistic. It's quite representative of what has been happening in reality.
And so the long time series is an important part of this for policymakers, because they can use it as a benchmark.
Yeah, and I mean, the time series is very important for researchers too. You can't really make inferences about change until you know what your baseline is. And of course, your baseline might change on an interannual scale, it might change on a decadal scale. So you need to be able to even get further than that in order to start to understand what the change can be attributed to. With policy, it's quite important to know what you have now. So what is a seasonal thing? What is your annual thing? And we all work on this through something called the Marine Strategy Framework Directive, which is it's a European directive. And the point of it really is to get the UK and other European countries to good environmental status by 2020. So we're all working under a similar motivation. We all want the same thing. We want good environmental status. We want it quite soon. And the framework is really good at helping us figure out how to do it and where to do it and under what sort of parameters we can do that. And some of these things can be measured by satellite. And that takes a lot of the burden financially and in terms of labour to actually collect that data.
Yeah. We're talking about things like not overfished and not polluted.
Exactly.
And those are things that decisions about what people do on land can influence those areas, and you can manage them because you know what's going on.
Absolutely. So we can't necessarily measure marine plastics from satellite, for example, but in the same way, that's a very good example of that interconnectability, because if you want to solve the marine plastics problem, you have to solve it on land. And it's the same sort of thing if you are having eutrophication issues, if you're seeing really high chlorophyll values and they're harmful algal blooms, and they just happen to be next to a farm or a golf course that is over-fertilizing, and you have a lot of rain and a lot of runoff, there is always a link between land and marine.
It's a complicated system. Lots of things are affecting lots of other things, and the better your spatial and temporal data, the more you know exactly where things are happening and what the changes are over time, the better you can try and understand that system.
Absolutely. And that's why it's quite exciting to work in this kind of area, because ultimately you feel like you're just gathering puzzle pieces and you go, oh, this picture's becoming so much clearer. I didn't realize that connected to that. But there's something quite exciting about being involved in that process. So I really enjoy that.